In this video we're going to look at general solutions to differential equations. We want to solve for y here. So let's get all the y's to the left and all the x's to the left, to the right. So we're going to divide by y to get dy over y. We're going to multiply by dx to get 4x dx. Let's just have a look at where these are all coming from. If we have a function y is equal to 3x, dy dx would be equal to 3. Or dy would be equal to 3 dx. Now we wanted to solve for y here and get back to the original function, which is what we're doing here. We would integrate what would just be a 1 there that we don't see. 1 dy would be equal to the integral of 3 dx, and if we integrate 1 dy we get y, and if we integrate 3 we get 3x, which will get us back to the original function. So that's what we're going to do within these equations. So this is 1 over y dy. We're going to get the integral of that. Will have to be equal to the integral of 4x dx. The integral of 1 over y goes to the natural log of y. That's going to give you to 4x squared over 2, 2x squared. And we bring in a constant just on the right hand side. So this will be the log of y to the base e, if you want to write it like that, is equal to 2x squared plus c. So solving for y, e to the power of 2x squared plus c will be equal to y for this first example of first order differential equations. Now let's have a go at solving a few more. Number 1, 6y dy dx is equal to 6y. So dividing by y and multiplying by dx, we're going to get dy over y is equal to 6 dx. So that will be 1 over y dy is equal to 6 dx. Stick your integrals in. We're going to get the natural log of y, or log of y to the base e, I think we use more in class, is equal to 6x plus c. So y is equal to e to the power of 6x plus c for number 1. Number 2, if we divide by y, we get dy over y is equal to 2x dx. You can see when you do a few of these, you can start doing them in quicker steps. 1 over y dy equals 2x, I'm leaving room for the integral. So we're going to get log of y to the base e, or the natural log of y, is equal to 2x squared over 2, just x squared, plus c. So we're going to get y is equal to e to the power of x squared plus c. Number 3, if we multiply, we're just going to get dy is equal to cos x dx. And if we integrate dy, if you want to imagine that there's a 1 there, it'll be equal to the integral of the other side. So we get y is equal to cos x, and we get sin x, and then just add your plus c in. Solves quite quickly. Number 4. So we're going to multiply by y, so we're going to get y dy is equal to that's going to be equal to 4x cubed dx. So if we bring in our integral, integrating y, we get y to the power 2 over 2 equals 4x to the power 4 over 4 plus c. So we're going to get, if we multiply, we're going to get y squared is equal to 2x to the power 4 plus 2c. So y will be equal to technically the square root plus or minus the square root of 2x to the power 4 plus 2c. For, what question is that? 4. On to number 5. 5. If we divide by y, dy over y. Number 5, dy divided by y is equal to 3x squared dx. So we get 1 over y dy, the integral of, equal to the integral of 3x squared dx. So we get the log of y to the base e, or the natural log of y, is equal to 3x cubed over 3x cubed plus the constant. So we're going to get e to the power of x cubed plus c is equal to y. Question 6. If we were to leave the y there, sine 2x over y is equal to minus dy dx. Multiplying by y, or bringing, then we get y dy or minus y dy is equal to sine 2x dx. So we leave the sine with the minus, so minus 2x dx. And we integrate both of these, we will get y squared over 2 equal to, sine goes to minus cos, so we're going to get plus cos 2x by 1 over 2, or over 2, plus c. So y squared, if we multiply by 2, will be equal to 2 it's going to be 2 cos 2x over 2 plus 2c. So y is going to be equal to the square root of cos 2x plus 2c, and the plus and minus version of that. Number 7, we just multiply out the bracket. Dy dx is equal to 2x y squared plus 2x. So that in fact is a stupid thing to do. Divide by y squared plus 1, dy over y squared plus 1 is equal to 2x dx. So this is 1 over y squared plus 1 dy equal to 2x dx. Integrating both sides, this is our tan, where we're going to get 1 over 1 over the square root of this a squared and y squared by the inverse tan of y over 1. That's what that's going to give me. And that's going to be the 2x squared over 2, just x squared, plus c. So tidying this up, the inverse tan of y is equal to x squared plus c. Means that the tan of x squared plus c has to be equal to y. Then finally, number 8. If we divide by the square root of 1 over y squared, we get the inverse sine 1. That's equal to 2 dx. If we integrate these, we're going to get 1 over 1 by the inverse sine of y over 1 is equal to 2x. So we're going to get the inverse sine. Don't forget your c. The inverse sine of y is 2x plus c. So y must be equal to the sine of 2x plus c.